Hi, welcome to Hashtag Math. We're going to find x and y intercepts of rational functions. Let's look at them on the graph. The first graph here is the reciprocal function, 1 over x. We cannot plug in 0 because it's not defined, so it does not have y-intercepts. And as x approaches positive or negative infinity, the graph is approaching 0 and never touching 0. So this function is never 0. So 1 over x does not have x or y-intercepts. The other is a graph of a typical rational function. The y-intercept is where the graph touches the y-axis, and it happens here. So the y-intercept here is 0 for x, 1 for y. The x-intercept is where the graph touches the x-axis, so it's 1, 0. The y-intercept, 0, 1, and the x-intercept, 1, 0. Now we want to find the x-y-intercepts of G. It is always a good idea to start looking at the domain. What's the domain of G? It's the set of all real numbers except -1. We see that 0 is in the domain, so we can find the y-intercept. Remember, there's only one y-intercept, otherwise the function would not be defined. And to find the y-intercept, we set x equals to 0. So we are really finding G of 0, which is 0 minus 3 over 0 plus 1 squared, and that's -3 over 1, which is -3. So the y-intercept is 0, -3. Y-intercept done. Let's go with the x-intercepts, which could be more than 1. We find those when we set y equal to 0, that is g of x equals to 0. So we're setting x minus 3 over x plus 1 squared equal to 0. And remember this, any fraction, a or b, a number in the top, a number in the bottom, equals 0 if and only if the numerator is 0, as the denominator cannot be 0. So x minus 3 over x plus 1 squared is 0 when x minus 3 is 0. And then we solve for x. Add a 3 on both sides, get x equals to 3. That means that our x-intercept is 3, 0. And we are done. One more example. Let's look at the domain of f. So we factor the polynomial in the denominator, and that is x times 0, 2, 3, which means the domain is all real numbers except what makes the denominator 0, which is 0, -2, and 3. 0, -2, and 3. Well, now what happens? The function is not defined at 0. I cannot plug in 0 into the function. What does this mean? Well, there's no y-intercept. Now to find the x-intercepts, we set our function to 0. This equation is 0 when the numerator is 0. Then x equals positive or -2, and the x-intercepts are -2, 0, and 2, 0. Done! One last example. In order to find x-intercepts, we know we need everything from. So let's do that first. We can factor out an x in the numerator. Then we can factor the trinomial, x times x, a 1 and a 4, positive and negative. Notice that the domain of h equals all real numbers except 1 and -2. Whoops, how do we interpret what's happening here? We have a factor canceling out. Can that be an x-intercept? No, the function is not defined there. So to analyze this, the y-intercept is no problem. We can plug in the 0 because that is in the domain. So that's just h of 0. And when you plug in the 0 here, you get 0. So the y-intercept is just the origin. Now for the x-intercepts, we have to see the situation. 1 is not in the domain. So 1 cannot be an x-intercept. This equation is 0 if the numerator is 0. And the numerator is 0 if x equals 0 or x equals 1 or x equals -4. But x equals 1 here is not an x-intercept. It's not in the domain of the function. So my x-intercepts are the origin, which is the same y-intercept, and -4, 0. And we're done. Thank you.